Okay, this video is about CDFs, cumulative distribution functions. Now this is what I was talking about earlier, where we integrated at the start and we just keep using the integral rather than reintegrating it each time. So a CDF is the integral. So it's this formula in our reference sheet with the R. Remember that they changed to an X. In your textbook it says f of x and it's got an X. I've used R because that's what's on our reference sheet. Okay, so it's a function of R, which is the same as the probability x is less than R. It could be less than or equal to R. Remember, that's the same thing for continuous. A is the start of our domain, and it goes up to R, and R also has to be on our domain as well. Okay, so let's have a look at an example. So a continuous probability function is given by f of x equals x cubed on 20 on the domain 1 to 3. We don't have to prove that that is a probability density function. We're told that it is. If you did integrate it from 1 to 3, you should get 1, but we don't have to do that. Find the CDF, find the cumulative distribution function. So that just means integrate. So the probability that x is less than or equal to R, it doesn't matter if you use less than or equal to, straight from the reference sheet is the integral, in this case from 1 to R, okay, of x cubed on 20 with respect to x. So we're just saying from 1 to any value, really. So it's x to the power of 4 on 4 times 20 from 1 to R, which equals, plug in the R. So you can see if that was an x as well, it's kind of confusing. So R to the power of 4 times 20 is 80, minus, plug in the 1 to the power of 4 on 80. You can leave it like that. I prefer to just put in the 80 once in my calculator. 1 to the power of 4 is just 1, of course, over 80. So I tend to write it in that form. So we're going to now use that to find some probabilities. So when it says the probability x is less than 1.3, all we have to do is plug the 1.3 into that formula. So 1.3 to the power of 4 minus 1 over 80. Now when you put that in, when I put that in my calculator, it actually gave it to me as a decimal. With probability, we tend to do a few more decimal places. So I'm going to do 4 decimal places. So 0, 2, 3, 2 to 4 decimal places. So the probability it's greater than 2.5. So this is a cubic function. At some part it's going to look something like that. Remember, it goes from 1 to 3. Okay. We want to know greater than 2.5. We want to know this area. So all we need to do is 1 minus the red area. Okay, I'm going to draw that as a diagram. So my blue shaded area equals, I'll take away that equal sign, 1 minus my red shaded area. So this would equal 1 minus the probability that x is less than 2.5. Okay, and then I just need to put 2.5 into my CDF. So it's 1 minus 2.5 to the power of 4 minus 1 over 80. My calculator did give me a fraction for that. Fractions or decimals are fine. I think at one point in my very first video I said written as a decimal, that is, and then I gave it to you as a fraction. It doesn't really matter which one you use, they mean the same number. Okay, so the probability is between 1.2 and 2.3. So as with my previous diagram, let's have a look at that. So we're defined from 1 to 3. So we want from 1.2 to 2.3, we want this area here. Okay, and to find that, what we do is we do the probability that x is less than 2.3. So that's all the way from 1 to 2.3 minus the probability that x is less than 1.2. So we're just minusing off this little bit that I haven't shaded there. So then we're putting those numbers into our CDF. So it's 2.3 to the power of 4 minus 1 over 80 minus 1.2 to the power of 4 minus 1 over 80. Again, my calculator gave me a decimal here. To 4 decimal places, it was 3239. There is one more thing in this exercise which I'll record in a separate video.